Here with again, my name is Taz Khalil. I'm a product manager at Broan Newtone. I've been with the company for a little over 2 years now, mainly focusing on this product here that I'll be presenting to you guys, which is our Overture indoor air quality system. I'm responsible for product development. I'm also responsible for channel development and marketing. So between that, my engineering team, our internal Broan Newtone team, and the Pure Tech Alliance, we are here to support you in any way that you need, whether that's product training, whether that's, hey, I don't know where to download the app or whatever it is. I'm here to be your go-to guy. I'll kind of point you in the right direction if need be. But again, been with Broan Newtone for about 2 years. You may familiarize yourself with the especially the Newtone brand in this industry a little bit, as we did play in the kind of integrator space for quite some time. We actually developed all sorts of different products, whether they are intercoms you might be familiar with from back in the day, to CVACs and other technology related products that we released in the market. Since then, we've kind of taken I'll say a hiatus from technology and kind of had I'll say a shift in focus on really focusing on what we know best, which is ventilation and indoor air quality, right? For us, we believe, and our motto truly is, better quality of air provides a better quality of life. And for all we do, whether it's this product that you're seeing here, or other products in other segments of Broan Newtone, each of us are kind of striving towards the mission of providing better indoor air quality. So if it's not doing that, it's most likely not part of Broan Newtone. So I'll give you a little bit of an overview of what we're going to talk about today, how we're going to cover it. But just to kind of summarize what I have on the screen here, it's basically the why. We're going to talk about the why behind indoor air quality, right? Why is it bad? Why does it need fixing? The what, right? The what is indoor air quality? What makes up indoor air quality? Kind of breaking it down at a little bit of a scientific level to understand, what is good indoor air quality and what is bad indoor air quality. And then lastly, we'll talk about, the how. How can we get better indoor air quality for ourselves, for our clients, for our builders, our retrofit applications? We'll be able to kind of walk you through that, and hopefully it'll be a kind of easy discussion. Again, I encourage you guys all to use the chat feature here in Zoom. At the end of the presentation, I'll spend some time kind of going over either specific questions that you guys have or any level of questions that may come up during the presentation. I'll circle back to those and make sure to cover those. So without further ado, let's kind of get into it, right? So again, being with Broan Newtone, focusing on indoor air quality. Traditionally, our biggest target has always been home builders, right? If you're familiar with Broan, you are probably familiar with Broan being, the bath fan, or sometimes we're called the fart fan company. But that's the biggest part of what we do as an organization is bathroom exhaust ventilation. In addition to bathroom exhaust ventilation, we also do kitchen ventilation. So including things like range hoods in homes, or under cabinet hoods, or even recirculating hoods, right? And then beyond that, we have a product line of what are called fresh air systems in the industry. These are products that kind of bring fresh air into the house. And now more recently, Overture, which is the product that I'm showcasing here. But I mentioned, again, our focus has always been builders. We do work a lot with retrofit as well. But what we've seen is really a trend in kind of home building techniques and strategies that unfortunately have made indoor air quality suffer as a result of these techniques, as kind of ventilation and indoor air quality has been kind of on the back burner for some builders. And truly, it's become a little bit bigger of a problem than we expected to. Typically, you think of, a newer home, I'm in a new environment. This must be better than my last one or my old home. And unfortunately, that's typically not the case, right? We've gotten so good today in our building construction techniques that we have essentially done a great job of insulating our homes, of closing up every crack and crevice that we could find in our windows, in our doors, in, other aspects of our homes. And so today, when we look at kind of how homes are built with spray foam insulation, with other construction techniques, they've become very energy efficient. And that's a very good and bad thing at the same time, right? It's good for the energy bill. It's good for the occupants that are staying in that home in regards to what they're paying month to month from an electricity perspective. But on the flip side, it also means that all the stuff that you're generating within the home, all the daily activities that you take that increase the humidity in the home or increase the level of particulate matter in the home or create odors or whatever it may be, are also being trapped within the home as well. So the home has kind of become this kind of plastic bag essentially that we're breathing through, that all of our families are breathing through. And unfortunately, even trends have shown things like windows being open less frequently. Definitely, where I live in Milwaukee, Wisconsin, which is right up here on the map, you could see it's a very cold and bitter region. It's 32 degrees outside. I'm not going to open my windows probably for the next couple of months. And as a direct result of that, we've seen states, local municipalities, of their governing agencies essentially create what are known as kind of building and ventilation codes, or DUV, which is dwelling unit ventilation, basically stating you must have a minimum threshold of ventilation for your home to even be sold and get your permits and do the things that you need to do to be able to pass that home to the homeowner. So again, looking at it, every single state has their own level of ventilation codes. Some, are more stringent than others. If you go to California, it won't be the same than if you go to North Dakota, for example, right? But for most of the US, you'll have some level of code that you need to meet at a minimum. But of course, in our market, minimum is not a great word, right? We tend to strive for well beyond what the minimum is, over the minimum in everything that we do, right? For security, for automation, for indoor air quality now. And again, looking at how these homes are built, you could see spray foam insulation, you could see the different types of caulking materials that they use on windows, and windows are getting super efficient now where it's practically no different than just a wall, whereas before with single pane glass windows, it might as well have been just a hole in your wall, right? So the differences in construction techniques have really elevated the, I'll say, tightness of the homes that we're building today. If you kind of if a myself personally being a real big numbers person, I have a degree or a background in engineering. I always kind of like to look at the numbers. I'd love to hear people talk to me, but if I were in your situation, I'd ask, Taz, show me the numbers. I'd love to understand this a little bit more. And this is a study that a company called ASHRAE does, which is essentially the governing agency for a lot of these codes that I talked about earlier. Does. And what they do is they basically prescribe a level of home tightness, or they take a look at home tightness over the years. And back in 1975, we do this thing called a blower door test in this industry, where we basically pressurize the house to a certain rating, in this case 50 pascals, and then we're able to see how many air exchanges per hour there are in that home, and that's the value that we use for the tightness of that home. In this scenario, in 1975, your average home had an air exchange per hour of 12. So in this case, a little over 5 minutes, basically, or exactly 5 minutes, you would get one whole air exchange in the house. So every molecule in that home would, change from being inside to outside, or outside being inside. Again, this is under 50 pascals of pressure. So in realistic scenarios, it'll be a little bit, a lot less, but they pressurize the homes to ensure that there's a level playing field here. Nowadays, with our construction techniques that I talked about, typically we started doing this very heavily right around 2008, when, again, the recession happened and people were focusing on building homes as tight as possible. we have now gotten to a point where your average is anywhere between the 3 and 2 range now. I've personally seen, working with a lot of builders and kind of visiting all over the country, blower door scores as 0.5 under 50 pascals of pressure, which, I mean, equates to basically a plastic bag over the house, for lack of a better term. So you could see how all this stuff that we're creating in the home is now kept in the home. And this kind of is the portion of what is indoor air quality of the presentation, really, right? We talked about how we're trapping all of these pollutants inside of our home. Well, your next question, I think, should be, well, what are some of these pollutants, right? What makes indoor air quality good and what makes indoor air quality bad? And it really comes down to, good indoor air quality is pure of any pollutants in its space, right? You could kind of think about it like water, right? Anything in water typically is bad. Water is a little bit different, where you could add certain minerals and things to make it a little bit better. But generally speaking, you want to take all the stuff out of water, right? And then that makes water a lot healthier, a lot better for you. So same thing with air, right? We want to remove all this stuff, these pollutants, these foreign objects from our air that we breathe on a day-to-day basis. And when we look at indoor air quality, you could break it down into 4 different categories of pollutants, really. One is CO2, again, just a byproduct of what we breathe. So I take a big breath, I breathe in oxygen, and I breathe out a bunch of CO2. If you were to breathe into a bag repeatedly over and over and over again, eventually you'd run out of oxygen, and that wouldn't be good for you. Again, that same analogy can be said, but now the bag is your house, right? You continuously breathe oxygen over and over again, and you expel CO2. Well, at some point, I'm not saying you're going to run out of oxygen, but at some point, the excess amount of CO2 in your home does cause cognitive function despair. It does cause all sorts of different, I'll say, health effects that we'll talk about here in the next slide. But generally speaking, you want to minimize the amount of CO2 that's in the air, and we want to make sure that we're doing that as efficiently as possible. The next point is humidity. We really want to keep humidity in a real optimum zone. So this is kind of the moisture level within the home, right? At the kind of 40 to 60 range, it's great. You could see how bacteria and viruses have that same kind of sweet spot where they don't really thrive very well in that kind of range. But get too high or get too low, certain types of bacteria and viruses can very easily grow in very damp or dry environments, just depending on what they are. Adversely, again, in a bathroom situation, perhaps things like mold and mites can grow in very, very wet environments, respiratory infections, again, dry environments. So ensuring that we're in that optimum zone can be very helpful to ensure not just the health of ourselves, but frankly, the health of the building as well. I've been into numerous homes where, again, way too much humidity has basically created, blue spotting on walls or on ceilings. We've also seen the adverse, which, very dry homes have essentially created environments where paint starts to chip and wood starts to creak, and again, creates more structural damage in addition to the health damage on ourselves. Additionally, another thing for indoor air quality that we should try to remove of as much as possible are things like VOCs. These are really gases or compounds that are mixed in the air. You can think of this as like if you dropped food coloring into water, for example, right? And now the entire bottle of water is blue. It's because it's mixed in. It's become kind of a homogeneous mix. And this can be done because of, frankly, all sorts of things. It could be cosmetics. It could be, you put on whatever it may be, hairspray in the morning. It could be air fresheners that we think are making the air cleaner, but in reality are adding things like VOCs and additional pollutants. It could be, cooking odors, bathroom odors, all sorts of different things. Smoking can create all sorts of different VOCs. Typically, if you could smell it, it is a VOC. But even things like the building itself, can cause VOCs to be in paint. You can see, again, new furniture is a real big one, where you might get all of these materials that haven't off-gassed properly, and therefore create that kind of new car smell that we're familiar to, which is in reality, again, not helpful and not definitely harmful for us. Additionally, the last one here is particulates. If I were to use the water analogy again, it's kind of like dropping sand in water, right? It's physical stuff that's not necessarily getting mixed in with the air from a chemical compound perspective, but it is in the air. And what I'm talking about in reality is oftentimes you'll see particulate matter noted as PM for the particulate matter portion, but the denotion of the number afterwards will typically indicate the size of it. So you'll see things like PM10 or PM2.5 or PM1. And what that does is it allows essentially us to be able to see the size of the unit. And when we start looking at things that are around that 2.5 range, you'll see a lot of, people talking about PM 2.5 specifically. And that's because that's the kind of specific size in which our body has a very hard time dealing with, right? When we talk about things like PM10, like pollen, for example, if you breathe in pollen, your natural response is to cough it out, right? We want to get rid of it from our body. Our body detects it and expels it. But when we talk about particulate matter 2.5 and smaller, what we're doing is actually breathing that stuff in, and it's getting into our respiratory tract. It's getting into our bloodstream. And if you're hearing all this and perhaps you're thinking, there's some studies I'd like to take a look at this, I'd heavily encourage you to look at all sorts of different studies from the EPA, from the American Lung Association. The best one that I've seen too, kind of around CO2, showcases the cognitive function decline in high levels of CO2. Nowadays, we're focusing on ventilation in schools to increase test scores, and that's kind of that correlation there that I was talking about earlier. So just kind of at a high level, indoor air pollution comes in many different forms. Some of them we can see, some of them we can't, some of them we can feel, some of them we can't, but they are there, right? It's unfortunate, but the biggest intake that we take as humans is not water or not food, but really air, right? We eat 4-ish pounds of food, we drink, a gallon or so of water a day, but for air, we're breathing in essentially the equivalent of 6 Olympic-sized swimming pools. So if you can imagine that being polluted and that entering our body, if we had, we'll say, one thing that we could focus on to improve the health of our customers and our clients, it could really be kind of boiled down to air being the most number one thing that we can focus on to improve their health. And when we look at the homeowner themselves, right, we can kind of see a lot of the different, I'll say buying tendencies that homeowners have. And even before the pandemic, Green Builder Media did a study where they asked a number of home buyers whether or not they were willing to pay more for a home. Excuse me. And what they found was an astounding 83% of individuals would be willing to pay more. So not just wanting better indoor air quality, but actually willing to pay out of pocket for improvements for their health. 13 or 12% said, no, I wouldn't be willing to pay more, and 5% were kind of on edge. I could probably bet a little bit of money and say, since the study was done in 2015 with the pandemic in 2020 and 2021, kind of looking at how that's shaped our minds around air quality and our focus on purification and ventilation, I would assume that that number has at least grown by a couple percentage points. And when we look at, how we can get better indoor air quality in a home, it truly starts with ventilation, right? There are products that can improve indoor air quality, like purification, but when we look at those at a high level, what they do is kind of purify or filter the air that's already in your home, but they really purify things like particulate matter really well. So they are not really taking care of things like humidity, for example. They're not really taking care of things like CO2 that I mentioned earlier. And the best way to really get better indoor air quality is, if you think of outdoor air quality as kind of being your baseline, is to kind of trade that outdoor air for the indoor air and thus ventilate essentially your home. And a very standard way of doing that, and one we're probably all familiar with, is a standard exhaust ventilation strategy. And what I mean by that is essentially using something like a bath fan to be able to exhaust that air out from a room like a bathroom or like a kitchen, a place that we commonly create a lot of pollution or a heavy amount of pollution, and then have negative pressure in our house that naturally sucks and brings in that fresh air from the outside in. Again, nowadays with homes being built super tight, that becomes a lot less effective when your home is very, very tight from the inside and isn't able to really, adequately draw that air naturally through the outside premise of the house. So a lot of individuals, a lot of home builders have kind of flipped that methodology, right? They've gone from going from an exhaust strategy to really a supply strategy, meaning instead of exhausting air out of the house, well, let's bring air into the house, right? Let's do the opposite and let the air naturally pressurize the home. And then we can get the pollution out of that space naturally through the cracks and crevices. But again, going back to kind of what we learned earlier, the ideal way to do it isn't necessarily just exhaust or just supply, because when we supply, we're able to actually filter that air. So we're able to make sure that outside air is getting filtered. And then when we exhaust, we're making sure that, if there is a place like a bathroom or like a kitchen where we can naturally remove a lot of those pollutants, we can do that very effectively. And thus came kind of the balanced ventilation approach for a lot of different builders and a lot of different ventilation strategies, where they bring in air and they exhaust air out. So they're filtering it right through some sort of a filter box here, and then exhausting it out of the home somewhere else, right? You could do this with a combination of an exhaust and a supply product. You could do this with a single unit, typically referred to as an ERV or an HRV. And that has a certain level of recovery as well. So you're able to not just do that, but also capture some of the energy in the home. So you're able to get energy efficiency and air exchange within your home at a very efficient rate. The only problem with a lot of these ventilation strategies, and this goes for every single one of those that I talked about earlier, is they essentially kind of quoted, if you will, based on the home. So they go to a home and they say this home is 2,000 square feet or 5 rooms, 3 bedrooms, whatever it is. And they go, this home needs, we'll call it 100 CFM or 100 cubic feet per minute of air exchange constantly, right? And then they'll employ one of those strategies. The issue with that is, in reality, right, if you were to take these two families side by side and build identical homes like the one you see in the middle, they'll have totally different ventilation and air quality needs, right? And this goes back to, the minimum is not always what's best for everybody. If you look straight off the bat from an occupancy perspective, you could see the family on the right having, 6 people and a dog, as opposed to the family on the left only having 2 people. So right off the bat, you're dealing with more CO2. Then we get into their habits, right? They work in office every day versus at home. They eat at restaurants versus cooking. They use natural cleaning products instead of bleach. They take shorter showers. And all this stuff typically adds up in terms of the amount of CO2, the amount of VOCs, the amount of particulates, and the amount of humidity in that home. Yeah. And as you kind of look at, every single one of these families, you start to slowly understand that it's not necessarily different homes that have different ventilation needs, but also different families and different styles of life that have different ventilation needs. And those ventilation needs also change over time, right? The family on the right here may have a kid that goes off to college, or they may adopt a cat, or they may, have a mother-in-law that stays over, whatever it may be. That changes their family dynamic and therefore changes the amount of pollution and ventilation that they need. So it would be great if we had a way to kind of look at that at a pollutant level and then do something about it. One other point too is, again, not all rooms are the same. So if we look at it kind of at a room by room level, right, we're able to look at the kitchen, for example, the family room, the dining room. Some of the rooms can be unoccupied for most of the day and have, okay or, all right air quality. But when you cook in the kitchen, or when you take a shower in the bathroom, or even when you sleep in your bedroom and you breathe with yourself, your significant other, maybe a pet in the same room, for 8 hours a day, you're creating all sorts of different pollution specifically in that room. And what matters is, what is the air quality around us, and what is the air quality that we're breathing in that moment? Not necessarily what is the average of the air quality in my entire house. Because if you may have a 5,000 square foot home and one room is bad, but every other room is okay, generally speaking, on average, your home is great. But if you're spending 8 hours in that room you're sleeping in, and you have a lot of CO2, you're going to still suffer those health effects that we talked about earlier, of a poor night's sleep, of reduced cognitive function, all the things we mentioned before. So we kind of need to take a look at indoor air quality at a room by room level, not necessarily just a single I'll say thermostat approach where we put one right in the middle of the house and we're good. And speaking of kind of measuring indoor air quality, another piece to the puzzle is that humans really are not great at detecting indoor air quality, right? If I were to ask anyone on the call, what is the CO2 level in the room you're in, your guess would probably be good as mine, meaning they're not very good at all. CO2 and some VOCs can't be sensed at all. Others, like particulate matter here's another study where they actually tested essentially human sensing capabilities of poor indoor air quality. And they tested what was called SWB, or their subject well-being. And as they continue to make the air quality worse and worse on the x-axis here, humans felt pretty okay, not really terrible, up until the 150 mark. But this was well beyond, or well past the needed ventilation or purification space, right, of around 40 here, to be able to take care of an issue that was present in that space. So even when we do detect poor indoor air quality, it's not really until it's at extreme levels or very high levels. And then on the flip side, for us individually, for certain pollutants, we really can't detect them at all. And so when we look at the market today, right, there's a lot of different products that can measure indoor air quality, right? If you go to Amazon, type in, air quality sensor, these are great products for us to kind of start dabbling in to understand what is the air quality in that space. But the unfortunate part is they kind of just tell you what the air quality is, and then it's up to you to figure out how to fix it or how to take care of the problem. And with, we'll call it a kind of thermostat or thermometer approach, it's a very similar mindset, right? A thermostat not just tells you the temperature, but actually takes care of the problem by running your air conditioner or running your heater to be able to provide you with a comfortable temperature. What we have today on the market is more akin to essentially thermometers that just tell you what the air quality level is, or tell you what the temperature is, and then it's up to you to figure it out. Whether you're going to add a heater, whether you're going to cool your place down somehow. And it would be great if we had an opportunity to kind of follow the thermostat approach of not just measuring, but acting upon. And at Broan Newtone, again, we've been developing these ventilation devices for over 90 years now. And what we do is kind of taking that next step in terms of ventilating. And what we've developed and our team has developed is essentially what's called the Overture system, which is an opportunity for us to take indoor air quality readings and then optimize indoor air quality based on those readings. We do that with a couple of different devices that I'll walk you through here in just a second. But with these devices, we can measure indoor air quality. We can control ventilation devices like your bath fan, your range hood, or your fresh air systems in your home. You can, set it up so that when there's an indoor air quality issue, your home is actually able to react to those. And so going back to the examples that I talked about earlier with, a home having 6 people and a cat, we're able to pick up on those CO2 levels. We're able to understand what those VOC levels are. We're able to tell you when they're good, when they're bad, when they're not so great, and we're able to instantly react before it becomes an even worse problem in your home. And we do that with a couple of different devices here. The easiest one I'll say to kind of walk you through is just our room sensor here. We have two different variation. We have one plug-in version for retrofit applications, and then we also have a hardwired kind of flush-mounted wall version for new construction. And each of these sense temperature, they sense humidity, they sense VOCs, they sense CO2 and particulate matter. So they measure all those things that I mentioned earlier that can really be harmful to someone's health and can actually provide you a reading with what those levels are. They have visual indicators on them, whether they're on the front here or on this specific model, they shine a light on the wall behind it. So with these devices, you kind of have the first step, which is kind of identifying, hey, there's a problem. These other two devices on the left and right are the devices that actually are capable of controlling the other ventilation devices within your home. So you're able to say, control something like your bath fan or your range hood with a wall control, or a fresh air system with a product called our smart plug. So you're able to bring fresh air into the house, you're able to filter fresh air and bring it in and distribute it to the rest of the home. A combination of these devices can make sure that every aspect of your home is covered, from your first floor, your top floor, to every single room. We did a house recently in Minnesota that had about 17 devices in it. And it was a breeze to set up and kind of integrate throughout the home. There's a lot of software behind the scenes that makes this product super simple on the front lines. You definitely don't need to be an indoor air quality expert to set any of this stuff up. Our sensors internally have automatic calibration. All of our thresholds are pre-configured, so you don't need to be an expert to know that 60% is really when you should start I'll say exhausting humidity, or 19 grams is when you should get rid of particulate matter. All of that is pre-configured and automatically adjusts to the home. And then there is a super simple, easy to use tutorial that kind of walks you through how to set it up and how to pair it to the phone that you have. We do have outdoor air quality monitoring as well. So in addition to knowing what the air quality level is inside of your home, we also know what the levels are outside of your home by using data from local weather stations. So we're able to regulate ventilation until outdoor air quality becomes better. So we'll temporarily pause if there's something like a forest fire nearby or a large amount of humidity, and we'll stop any sort of incoming air if there's outdoor air quality issues as well. So you're protected both inside and out with Overture. And then additionally, we can meet those same codes that we talked about for ASHRAE. So you can kind of work with a builder or an HVAC contractor and reassure them that this product does meet those ventilation codes that they talked about earlier. But again, those are just a minimum, not necessarily I'll say a dedicated number we should be striving for. Additionally, we are focused a lot on the integrator channel. We see you guys as being the kind of forebringers of technology to homes, the people that understand technology the most. Typically at Broan, we focus a lot on the electrical contractor and the HVAC contractor. But with a product like this, we felt it's really catered very highly and more towards integrators. And so we're focused on creating integrators' lives easier by working with systems that you guys use or maybe plan on using in the future. Out of the box, I'm not going to say it because it will go off behind me, but we do work with, I'll say, Amazon. I think most of you know what I mean when I say Amazon's product line, and then the Google Home system as well. And then later in Q1, we are looking at releasing drivers for Crestron Home, Control4, and Elan that'll allow us to not just, again, showcase your indoor air quality on those platforms, but use the actual air quality sensors to automate other things in your house, perhaps a purifier, perhaps other ventilation equipment that you may have connected through a different system, perhaps lights to notify you that your indoor air quality is bad. So you're able to kind of create this whole home of connected technology equipment that now offers health and wellness through Broan Newtone Overture to be able to give you a better sense of a package that you can offer to your clients, your homeowners, and the builders that you work with. So at a high level, I hope this has been helpful and helps each of you guys understand what we are doing. Again, my name is Taz Khalil. Please feel free to reach out to myself or your local PureTech representative. We are working with them to help deliver trainings. Personally, I am available for trainings. If you have a training you'd like to conduct in your area or a group that you'd like to work with, more than happy to head out wherever you need me. That's kind of my job.